Okay guys, this is a little walkthrough of the like Expeditions Delta in case you're having some trouble. Let's go through a few problems and yeah, I don't think you're gonna find this too hard. I just want you to do it. Hopefully you're not watching this after Expeditions. Okay, let's go through number one. So this is like finding multiple derivatives. This is just really good review. Zoom in a little bit here. This is really good review, getting you back in the habit of writing derivatives, and so we're doing more of this unit. What this says right here, this notation, see the 3 there and the 3 there, this indicates the third derivative. Okay. And right here, you're gonna see this one. You're gonna see this will be the second derivative, right? And then right here, this is, yep, that's the second, right? And so on. So just a reminder, that's what that means. And all it means is like take the derivative twice, is what that means. So here, let's take the derivative. So first derivative would be 20 over 15 x to the fourth plus 6 over 15 x to the fifth plus 5/12. And with the second derivative, that's going to be 80 over 15 x to the third plus 6 times 5, 30 over 15 x to the fourth, and then nothing here because it's going to go to 0. Oh, let me focus this. Here. There we go. Okay. And so one more. Third derivative would be, it says 240 over 15 x squared plus 120 over 15 x to the third. Okay. 240 divided by 15 is 16. That's 16x squared. Right at the side here, so we're gonna have 16x squared, and 120 divided by 15 is 8x to the third. That's it. So I don't think these will be that much trouble. I'm not expecting you guys to really struggle too much on those. That should be mainly a review. Just take the derivative, keep taking it. Good practice. But let's go over linearization. This is important. So the next kind of problem you're going to get are these what's called local linearization. They're not super tough, but they're pretty common in the AP test, and they're using a skill that you already know how to do. Okay, so let f be a differential function such that f of 0 is -3 and the derivative of -6. What is the approximation of f of -0.1 found using the line tangent graph? Okay, I'm gonna draw what's going on here a little bit, and then we'll go from there. So let's draw this. So we have f of 0 is -3. So on my axis, so we've got, I know this point is true right here, and I know that the slope there is -6. So let me just draw what the function could look like. Let's just say, I don't know, let's say the function looks like something like this. Okay. Yeah, I don't know what the function is doing, right? I have no clue what the function is doing. I don't know that from this. What I do know is that f of 0 is -3. I know that's true. And I know that its slope is -6. So that's what we have right now. Again, that blue, I made up that blue. But the red I know. The red I know is true, and I know that dark blue point there. And we're trying to find an approximation for f of -0.1 using the line tangent. So this right here in red, that's the tangent line, right? So what this is basically saying is, I don't know what it's doing all over here, but I can estimate what the value of the function is at this point, -0.1, by using this red line and then, just I'm kind of zooming in here a bit, but you're finding the value here, right? You're finding this, which would be f of negative 0.1. This is local linearization, right? This is, you have the tangent line, the equation of the tangent line, and you use that to estimate the value of a point that's nearby it. Because you do that, why? Because you don't know this blue thing. You don't know what the function is. The function is unknown. And I'll show you some more practice problems, but here's how it works. First, find equation of tangent line. That's it, which you know how to do. This is all over the AP test. I hope you guys remember. Y minus y1 equals mx minus x1, and you just plug it in, and everything is here that you need, right? That 0, that's my x1. That negative 3, that's my y1. That negative 6 is my m. Should I label those? Okay. This is the m. This is the y1. This is the x1. Okay. So let's plug it into our equation. We're going to get y minus negative 3. It's going to be y plus 3 because it's double negative. Y plus 3 equals negative 6 times x minus 0, which is just x, right? So when I simplify this, I'm going to get y equals negative 6x minus 3. That's the equation of the tangent line. So that was step 1. Step 2, plug in value, the new value, right? So what's the value I'm plugging in? Well, I used these values here to get my tangent line, to get the red. Now I gotta get that blue dot. To get that blue dot, you're gonna put this negative 0.1 into that equation. So right here we're gonna have y equals negative 6 times negative 0.1 minus 3. So negative 6 times negative 0.1 would just be 0.6. So we have 0.6 minus 3, which is negative 2.4. So back up here, that basically means that the coordinates here on this red line would be, put an arrow here, it would be negative 0.1 comma negative 2.4. Okay, let's do another one of those for practice. Let's do this one. This one's slightly different. So if you got that, you can go ahead and skip this. But if you were like, oh, what was going on there? Let's do this one. I may not draw this one, but I'll write it out. So we gotta find the tangent line. Always, if you're using the line tangent to the curve, you're approximating something, you gotta get that equation, right? So we gotta get the formula. So y minus y1 equals mx minus x1. What do I got? Okay, I got my x1 right here. I got my y1 right here. So my m's kind of funny. I'll come back to the m. We'll do the y's first. Y minus 5 equals some m. We'll come back to that, x, and then let's go plus 3 because it's double negative. Now my m is this, right? And now instead of just giving you the slope, it's just giving you a formula, but I know what to plug into this because I'm plugging in a negative 3. So we're going to put a negative 3 into this. Negative 3 plus 1 is negative 2. So my slope must be negative 2. Right? Do you see how I did that? My slope is x plus 1. What's my x? Well, my x is negative 3. So negative 3 plus 1 is negative 2. It's just an extra step. Okay, so now I've got my equation. I can leave it like that. That's fine. And we're just going to plug in negative 3.05 into this. So, and then solve. So it's going to be y minus 5 equals negative 2, negative 3.05 plus 3. Let's do it. So negative 3.05 plus 3 is just negative 0.05 times negative 2. Y minus 5 equals that. And then we're going to multiply these. Negative 2 times negative 0.05 is just 0.1. And then we'll move that 5 over. Plus 5 plus 5. y equals 5.1. Okay, so again, it's the same thing. You find the tangent line equation, which you guys should be good at. Like, you should know how to do that, because that's a review. The only change is once you do that, you plug in that value right there. That's it. That's local linearization, and so that's why I thought this would be pretty straightforward. Let's do one of these just for practice too. Again, these are very, very similar questions, but I'll go over it. Really common AP question. Super common to get an AP question like this with a table. Let's do 13 here. The rate of which the water in the tank is changing in gallons per minute can be modeled by the function R of t, where t is measured in minutes. The amount of water in the tank when t equals 7 is 32 gallons. Okay. Selected values of R of t are shown in the table below. Use a linear approximation when t equals 7 to estimate the amount of water in the tank at time t equals 7.1. Use proper units. Okay, so what time do I care about? Well, I care about 7, right? So this is what I'm concerned with, 7 right here, because that's what I want, t equals 7. Okay, so I know at t equals 7, my R of t is 2. And I also know that there's 32 gallons in the tank. So using a linear approximation, if you see these words, you should be thinking in your head equation of the tangent line. So you should be thinking this: y minus y1 equals mx minus x1. Right, that should be going through your head. So we need to identify what is my y1, m, and x1. I still need to get those. Well, the x1 should be pretty obvious to you, because you're seeing, so it's like the input, right? X represents the input. What's my input here? Well, time is my input. Time is what's going in. And what time do I care about? 7. T equals 7. So my x1 must be 7, okay? That's pretty straightforward, right? Now, what am I measuring? What's my output? Well, I'm estimating the amount of water in the tank. Okay, amount of water, quantity of water. Well, I'm told up here the amount of water in the tank at t equals 7 is 32 gallons. So y1, the quantity of water, must be 32. That just leaves the rate of change. Well, what's the rate of change? Well, R of t is the rate of change, right? It says right here, the gallons per minute, right? It's R of t. And what's my R of t? Well, it's 2. My R of t at 7 is 2, so my m is 2. Now that's the hard part, guys. Identifying the values is the hard part. Once you've identified the values, then you plug it in, right? So we're going to do y minus 32 equals 2x minus 7. And I want to figure this out at 7.1. Now I plug in the 7.1. Y minus 32 equals 2, 7.1 minus 7. That's 0.1, it's 0.2. It's going to be 32.2. I'll just go ahead and show you. So it's 32 plus 32, so okay, y equals 32.2 pounds. Okay, so really important with these is that you read the question really carefully. Read the question really carefully. They're all, most of these are linear approximations. So really, as I said, really common AP questions. See, this one's slightly different. Because, let's read this one. I won't necessarily do this one, but I'll read it with you. The temperature of an object in degrees C can be modeled by the function z of t, where t is measured in minutes. Right, so again, you can kind of think, okay, well, that's my input. Like, this is my x, right, and this is my y. I'll come back to that. The instantaneous rate of change of the temperature is -3. So here, see, R of t was not, this was my m here, because R of t represented the rate of change. That was not my output. Here, z of t represents my output. It is the temperature. That is what I want. That is the output. T is the input, and the instantaneous rate of change is given to be -3, right? That is the derivative. Because that's, my t is 10. My m would be -3, because I'm given that it's got a slope of -3. And then my output, my y1, would be from right here, would be 15 from the table. And then these steps are just the same thing. Plug it in. The hard part is just identifying it. One more I want to do again. So, oh my god, this one's is on the test every year. It's a gimme. It's honestly a gimme, but you just need to like know what to do when you recognize it. The temperature of an object, all right, can be given by the function of t, where t is measured in seconds. Select values of t are measured in the table below. Use the table to estimate a prime of 7.5. Okay, so this is like, again, it's the slope of 7.5. Indicate the units in your answer. Okay, yeah, it's a great question. Very, very common. Super, super common. So you have these times right here. Let's like draw this out for a second. So you see what's going on. Okay, so we got like a 70, 85, 100, 109, 112, whatever. Okay, doesn't really matter. And then okay, this is 0, 5, 10. It doesn't really matter. 13, 16. This is just kind of show you. Basically, we have like, I don't know if it's some sort of curve right here. And what it's asking you to do is, I want the slope of this right here. That's what it's asking for. It's a 7.5 right here. And it wants the slope of that right there of 7.5. Right here, this is the derivative of 7.5. So how do you get that? Well, in this, we can actually estimate that slope of 7.5 by taking the average rate of change between 10 and 5. So remember, if you remember average rate of change, it's f of b minus f of a over b minus a. So in this case, f of 10, 100, minus f of 5, 85, over 10 minus 5. Let's do it. That's just 15. That's 5 on bottom. That's going to be 3. So your rate of change is 3 degrees per second. Yeah. 3 deg per sec. Okay. Degrees C, technically. Okay. Does that make sense? So you're given a table, you're given some values, you want to find the rate of change at a specific point that's not in this. Like, I mean, even if 7.5 was on here, I don't know the derivative of it, I just know the y value. You get the rate of change by you estimate it by taking the average rate of change of the points around it. So because it was 7.5, right, I should have labeled this. 7.5 is right in the middle of these two. Right, you see that? It's like it's a midpoint of 5 and 10. So because of that, I take the average rate of change of 10 and 5, and that gets me an estimate for what that slope would be here. Similar, if it's like 2.5, you would do this one, right? If it did 11.5, would be there, and then this would be 14.5 be there. Okay, so it's like the midpoint, whatever the middle of the times are. That's those. What else we got here? These are the same. Yeah, that's the same kind of thing we talked about. These are different. Let's talk about these. These are intermediate value theorems. These shouldn't be too bad either. These should be okay. This is review intermediate value theorem. Just getting used to it. Again, really common AP question, super common. Selected values of the continuous function f are shown in the table below. Determine the validity of the following statement: f of x equals 5 has at least 2 solutions. Okay, so if you're like stuck on this, one thing I do recommend that you do is just you kind of sketch that curve, or sketch the points rather. So 1, 4, 2, 6, 521, 845. So if you were to connect these dots, right, you just get like kind of a line going up or a curve going up. And if you think about where f of x equals 5, this is 5 right here. So right now, as it stands, this is guaranteed to cross at one time. It's guaranteed. It has to happen one time, not twice. It has to happen once. So could it pass it twice? Yes, it could. Because what could happen I'll do it in red, is that it could go up like this, and then it could come back down and come back up, to make that a little steeper, and go like that. Okay, so that would mean I had 3 solutions, which would mean that it does meet the requirement, right? So it could. This is a could. This is C, because it could hit it twice or it could not hit it twice, but it's not guaranteed. Versus, let's look at this one over here. Selected values are shown. It is known that the derivative is positive, right? So what this is saying right here, this is saying that always increasing, never going down, always going up, right? That's what that means. Always going up. Determine the validity of the solution. Okay, this is kind of similar problem, but slightly different. Again, drawing it out is always helpful. We have 3, -4 down here. We have 5, 4 up here. We have 6, 12. And we're told that f of x equals 5 has one solution, 5 being right here. Well, if it's always increasing, it might be shallow and it might be steep. Oh my goodness, sorry. But it's always going up, which means that it has to touch this once. It can't go back down. It cannot do this. Right? It cannot go up and then come back down and go back up again, because it has to always be increasing. So this is very common too. Like, you'll be given the table and then you'll be told, oh, by the way, the derivative is always positive, meaning that's always increasing. So that, and then that affects your answer. So these are great problems. Last one, trig, a little bit of trig. Let's do like one of the easier ones here. Let's do this one right here. This was on your, I think your second unit test. I gave you a problem similar to this, which nobody got, or sorry, I shouldn't say that. A few people did get, but you all struggle with it a bit. So that's why I'm giving it back to you. This is review. A good review, because we're going to have to do some more trig this unit. You know how to do this part, equation of the tangent line. We know how to do that, right? That's just what we did earlier. That's y minus y1 equals mx minus x1. Where you all struggle with, though, is the scary trig. The scary trig. Let's talk about it. So, what's what here? Well, we know what the x1 is pi over 3. That's a gimme, right? That's given. It's x, it's your x1s. Okay, so we have y minus some y1, we'll come back to that, equals some m, we'll come back to that, x minus pi over 3. What we need to fill in, and what I'm sure that you all can get here, no problem at all, but maybe you're struggling with the next part because, okay, I don't know what cosine of pi over 3 is. Okay, let's talk about that. So, it's okay. Like, I don't, honestly, I'm sure many of you don't know what cosine pi over 3 is, but I want to teach you to stop being afraid of the trig, and when you get to one of these problems, like, figure it out using the unit circle. So for me, I'm going to walk you through drawing a unit circle. You come to these problems, you draw a unit circle. Okay, let's draw it. We have 0 right here. Remember, the whole thing is 2 pi. I mean, you have to know some basic things. The whole thing is 2 pi. This is 0. This is pi over 2. This is pi. This is 3 pi over 2. I think this is a good, if you can do this, okay, you're off to a good start. Unfortunately, pi over 3 is not one of the corner points. The corner points are all really easy, because this is 1, 0, this is 0, 1, this is -1, 0, and this is 0, -1. So the corner points are all easy. Remember that the cosine is the x value and the sine is the y value. This is pi over 3. Within this little corner here, we're going to have 3 more. We're going to have pi over 6, pi over 4, and pi over 3. I would say you should be able to do what I just did. Like, you should be able to do this. Like, this is, get to this level. Get to this level where you can, okay, draw the thing, draw the circle. You can draw the corners, points. And now let's look at these 3. There's a pattern to these 3. It is really, really helpful to understand. What you do is you just write 1, 2, 3, 3, 2, 1. I might need more space in this actually. It's kind of low in space. Okay, let me do it around here. I'm gonna kind of zoom in on that. Not bad. You have pi over 6, pi over 4, and pi over 3. And you have 1, 2, 3, 3, 2, 1, over 2, over 2, over 2, all of them over 2, square root, square root, square root, square root, square root, square root, comma, parentheses, comma, parentheses, comma, parentheses. Those are the answers to each of these. And all you have to remember is that the x is cosine and the y is sine. Boom. So if you remember that little trick, you can get all the answers you want. What do I want? I want cosine of pi over 3. Cosine of pi over 3 is 1/2, right? Root 1 is just 1, right? So this is 1/2. So we come up here, what I really have is 2 times 1/2, which is 1. Okay, so my y1 is 1. And now I gotta get my derivative. So derivative, I gotta take the derivative of this. F prime of x is negative 2 sine x. Okay, and now I gotta plug in my pi over 3. Okay, well, I don't know that. Okay, well, I'll come down here. It's root 3 over 2. So this is negative 2 times root 3 over 2, which is, those will cancel, so we'll just have negative root 3. So this is just negative root 3. So I think you all are going to kind of struggle with these a little bit because you know to write this. Obviously, you know how to get the x, but when it comes down to these two, I'm a little worried that you're going to get scared. On the AP test in general, like, this is the kind of thing they're giving you. They're not really going to give you the 5 pi over 6, so that's not as common. And I think for those, like, okay, I mean, you can get by putting that in the calculator for right now. Even if you just understand the process of this and like what to do, that's what I want. If you do, let's just say you're trying to get 5 pi over 4. I mean, I can complete the circle, and I would advise you to get to the point where you can complete the circle. So, where you would have, essentially the circle just repeats itself over and over again. So that's pi over 4, that's pi over 2, this is 3 pi over 4, that's pi, this is 5 pi over 4 right here, and then that's 6 pi over 4, and this is 7 pi over 4. So right here, where if I came across a 5 pi over 4, I could keep building out my unit circle until I got 5 pi over 4. And this whole like 1, 1, 2, 3, 3, 2, 1 pattern just stays the same. The only difference is that you have to worry about like if it's negative or positive here. So see, we're getting down below. So in this way, like, it would be, the coordinates of this point would be negative root 2 over 2, comma, negative root 2 over 2, because both of the x and the y are negative. So using both of those, you could figure out pi over 4. If you don't get it, if you don't really get the unit circle, that's okay. Use the calculator though and still solve it. I just want you to understand what to do. So solve it. Good luck with this. I'll see you very soon.